is we're gonna talk about the trig derivatives. So a lot of you guys need to worry about is the trig derivatives. The trig derivative is something that's gonna happen a lot of times. So we're gonna talk about that. So what if I have d to the dx of, that just says if I have a sine of x, right? You guys should know what's derivative of sine of x is equal to. What is it? Cosine of x, right? And what's derivative of the cosine of x? Negative sine of x. So you gotta understand, every time you have c, you're gonna resolve with negative. That's the easiest way to think about it. Derivative of any trig function with a c always end up to be negative. Always. Only the derivative though. And I'm gonna show you something that we're gonna learn today is the other two. So d to the dx of tan of x is equal to secant square of x, and d to the dx of secant of x is equal to secant of x, tan of x. Okay, so, and then also by looking at pattern recognition, so usually I memorize those three, and the other side I just memorize the pattern. What do you think cotangent of x is going to become if derivative tangent of x is the secant square of x? Cosecant square is correct, but you're missing something. Negative. Yeah, anything you would negative cosecant, cosine, or cotangent, and anything with c is always end up to be negative, so you had to have a very discipline on that. And d to the dx of, let's just say, cosecant of x, according to pattern, what do you think is going to be? Good. Cosecant of x and cotangent of x. But what else missing? The negative. So what it comes down to, I always told students just memorize those one. And I'll memorize those three. And the other one is all pattern. And just I write down before the test, I'll write down derivative of sine of x, derivative of tangent of x, derivative of secant of x, and I'll write it down those before I do anything else. So, then, now I'm going to show you how to take a derivative. How do you get secant square of x? How do I know it's secant square of x? If I had d to the dx of tan of x, now what happened is when I take a derivative of tan of x, it's same thing take a derivative of sine of x over cosine of x, would you say? Now since we have a quotient, can we do a quotient rule here? Can we apply the quotient rule in this case? Yeah. Low, right? D high. What's the derivative of sine of x? Minus high, d low, over low, right? So that's going to be cosine square of x. Now this one's going to be plus sine square of x over cosine square of x. Now what do you think my next step is? Yes?
You have the identity for the cosine squared plus sine squared equals 1.
Good. So remember that identity for a reason. So it'll be 1 over cosine square of x. And what's 1 over cosine? And that's how they come up with the secant. they don't like everything is always like a proof from one thing to the other thing. It's not memorization. So a lot of time you can actually derive all this equation if you really wanted to. How about derivative of secant of x? This one's kind of hard, but basically just derivative of 1 over cosine of x. Now since it's 1 over cosine of x, it can be done with a quotient rule, right? Because that is a quotient. So what's the derivative? What is in this case? Low, d high. What's the derivative of 1? 0. So go away, right? Minus high, d low, which is negative sine of x, over cosine square of x. So it would turn out to be sine of x cosine square of x. That's equal to sine of x over cosine of x times 1 over cosine of x. And that becomes tangent of x times secant of x. So it'll be secant of x, tan of x. Okay, so you had to memorize all 6 of them for your test because you're gonna have probably test this Friday about all the stuff, and you have to go through all those extents. So any question about this part? I will make an index card just for this, and for this, and for this, and the other side is all the counterparts of it. So yeah, so in my, I actually told you like one of my students that he will run for mayor in a couple of years, and his name is Bobby Cena. He's a very, very cool kid. I really like him. He scored a perfect score on SAT without studying, but he failed my class miserably. So, so now before he failed my class, we were talking about this, and it's funny because he will always cheat on my test. And now we'll find out because every time before the test, he would take this huge glasses about this big, and he never wear glasses. So he'll put his glasses sitting next to the smartest kid. And, so he will like trying to look at her test. And I always catch him because he did it so obvious. Every time before a test, he would put the glasses on. But really funny kid. I really like him. So the only thing that he ever contribute in my class is he makes some like inappropriate term to describe the derivative of this. So I'm gonna make it more appropriate for you guys. So because I know like sometimes people might get uncomfortable. But anyway, so you think about derivative of tangent, right? So if you have 10, you must be like twice as sexy. So secant square, right? So, and I actually use different thing on BC Calc because that class is more inappropriate in many ways, so they don't mind. Derivative is secant of x. So if you want to be sexy, then you must have a sexy 10. So that's the way I remember it. So to help you. But anyway, you can do whatever you want. But he actually have all the inappropriate things happen in every single one of them here. I feel uncomfortable for saying it. But you can go think about it. And that's one way he remember it. So, yeah, he failed my class, but he did make some contribution to my class. Okay, so anyway, so that is derivative of secant. So today you're gonna have to find equation of tangent line. So you have to know your secant value is, secant of pi over 6, tangent of pi over 3. You have to know all that because that could be on your test. Because I could ask you equation tangent line, I could ask you horizontal tangent, I could ask you a lot of things. Now the next thing is that I will tell student is this. Make sure you understand um, how to find horizontal tangent as well. So, and something else. So I'm gonna talk about higher order derivative. So higher order derivative. So what is higher order derivative? Now let's talk about notations, right? If I have an f of x or y, now if I take a derivative, that's gonna be f prime of x. Does that make sense? Or it could be y prime. That's the notation. Also other notation, it could be dy dx. That's another notation for derivative. Or d to the dx of f of x. That's also means derivative. Because this is called notation fluency. You have to understand the notation in order to do well on AP exam. So sometimes they show up like this. Now to be granted, this one never show on AP exam. Only the first four will show up on AP exam. Now if I do second derivative, it's just double prime. Sometimes you need a second derivative because sometimes you got a physics. Anybody taking physics right here? Okay, so physics has a relationship between position, velocity, and acceleration. If you take a second derivative, that means it's an acceleration of the motions. So this is second derivative. And if I do second derivative here, it's going to be d2y dx2 or equal to d squared of dx squared of f of x or equal to dx to the 2 of y. Something like that. So that's the second derivative. In physics, you also deal with third derivative. In physics, you actually talk about something, sometimes people talk about a jerk. So it's going to be the third derivative. So it'd be y to the third prime or d3y dx3 or d3 over dx to the fourth or 3, sorry. Can't do. So that's just a notation wise that people are gonna have to see. Now, for something that is more than that, usually you don't represent in the prime anymore because you don't want to, if I want a 73rd derivative, I don't want to write down 73 primes. So usually after third, you're going to write down the number. So it'll be the fourth prime. So this is 4. That's not power of 4. That just means take derivative 4 times. Or y to the 4th like this with a parenthesis. So that's something that you will know. So it doesn't matter if n derivative just place that prime as 4. That means 4th prime. Now why that is important? Because sometimes you will get a function and we says, hey, what is the f of x and what's the derivative of a sine of x? And one of those most annoying question from 3 or 4 years ago when one of my students take AP exam, she says there was a one test question was like this. It says f of x equals sine of x, and she says she had no idea what this means. And same thing as like hundreds, thousands people who take the test, they also didn't know why the AP exam asked them to take derivative 73rd time. So, and maybe you guys can figure out why that is, right? I know Laura's already know because I already talked about it. But how about the rest of you guys? What do you think of 73rd derivative is? Yes.
It's where you take derivative of sine of x, so then it becomes sine of x, and then you just take derivative of cosine of x, so the negative sign.
Yeah, so are you going to take it 73rd time? No, right? Yes.
It's like a whole pattern going with it. I think there repeats like intervals of 4.
Very impressive. How do you know that?
So if you look at it, start with sine of x is then negative sign would be negative cosine, putting you back to sine.
Yeah, so I'm going to show you what he said. He said the first derivative is going to be cosine of x. The second derivative is going to be what? Negative sine of x. Does that make sense? The third derivative is going to be negative cosine. The fourth derivative is what? Is equal to positive sine, right? Does that make sense? And the fifth derivative is what? Cosine of x. The sixth derivative is going to be what? Negative sine of x. But he says after the 4 times, there is a pattern of 4. So what will be the 73rd derivative? Yes, Cindy? Negative cosine of x. It's a good try, but it's not it. It's just cosine of x. That's okay though, but a good try. Sometimes you're gonna think about how did people get to the answer, but it's worth it to always try, and it doesn't mind. And I'm very proud of you for that, because it doesn't matter right or wrong. You give a shot at it and see what happened. In this case, yeah, it is cosine of x, and there was a reason for that. Because if you can take a 73 and you can just divide it by 4, because we know pattern repeats 4 times each time. So that's just going to do 1, and that's going to give you 4, 33, long division. It's going to be 8, 32, and that's 1. So if the remainder is 1, so do you guys remember this? 18R1? Elementary school. Nobody write that anymore. But that 1 is the in computer science is called a mod. Mod is just looking for the remainder. In this case is 1. Also in number theory, which is something I'm very bad at, although it's math, but I'm very horrible at it, which is number theory. So it's also think about the mod of, the 73 and 4. So that's gonna give me 1. So therefore, the remainder is 1. So that means you're gonna repeat 18 times of the cycle, and then it's gonna jump back to the first one, because remainder is 1. If remainder is 2, then it's gonna go to the second derivative. Does that make sense? So it's gonna go through 18 times the cycle, and once the 18 times is finished, it's gonna jump back to. So this is gonna be as 72 derivative, because it goes into 18 times, and then the 73rd derivative go back to here. Does that make sense? It happened to a lot of things. It happened to I. You guys done in the pre-calc was I. I squared is -1. I to the third power is -I. I to the fourth power is 1. And I to the fifth power go back to I. So it kind of power of 4. And it actually happens everywhere. It happened a lot of things. I remember one of my old SAT questions like this was like 7 to the, 741 power. And obviously, if you type in 7 to the 741 power, it's going to go to undefined, because the number is so big that they can't even calculate. And the way that they ask a question, they say, what is the last digit of this number? They say, what is the last digit, right? What is the last digit? Then you will find out that 7 to the 1 power is 7. 7 to the 2 power is equal to 49, but only 9 is, pay attention to 9. And 7 to the third power is 343. But again, it's only the last digit is multiplied by 7, and you're going to get a last digit. And 7 4th power, I believe is 2401, but I don't know. Somebody can double check me. It's just 7 to the 4th power. But you see the last digit is 793. And if you 3 times 7, it's going to be 21. So only in the last digit I'm interested in. Now, if it's 7 to the fifth power, it's going to go back to the 7 because 1 times 7 is 7, and 7 times that is going to be 9. So let's say 741, again, it's going to go through. So it's going to be 1, 4, 34, 8, 32, 2, 1, 5. So it's going to go 185 cycles, and then remainder still 1. So therefore, last digit is going to be 7. So this happened a lot everywhere in math. It's a pattern of 4. And that's very, very important. Questions about this? Yes? Okay. Now, what are you going to get sometimes? So today, you're going to have to be able to, some applications. How do I find horizontal tangent again? How do I find a horizontal tangent? You guys are looking up, but think about it. Tangent means slope. Horizontal means what?
Zero slope.
Zero slope. That means I have to take a derivative, set it equal to 0. So today your homework, you might have some trig function. You have to take a derivative, set it equal to 0. Does that make sense? And solve for that x. Now today, are you solving for x? It's a little bit harder than last time, because this time it has a lot of different things. Question about this part. How much time I have? Huh? 10 minutes? Okay, let's talk about one more last thing. It's called generic derivative. But I'm gonna, you know how like a YouTube, there was like a video feed something, right? What does that mean, feet? Like F-E-A-T.
Like, kind of like they're like alongside, I guess.
Okay, so I'm gonna do that here. I'm trying to be cool. Okay, feet, graphing. That doesn't even make sense, but whatever. So feet graph. So what I'm saying is generic derivative. They can be a graph. They could be a table. So today you're gonna have a table, or you could have a, just a values, right, of charts, right? Charts and table are the same thing. So you're gonna have like this. So generic derivative. What is a generic derivative? So sometimes I will have a graph here, and I'm gonna do like this. There was particular things I'm looking for. So this is, let's just say, this line is f of x, and this one is a red line like this. Like this, and we can call it g of x. And this lines keep on extending. Yeah. So this point here. So we're gonna say h of x is equal to f of x times g of x. And we says, hey, can you find out what is f prime of, I don't know, f prime of 5? So you say, wait, what does that mean? That means what do I have to do? I have h of x equal to f of x times g of x. What does that mean if I want an h prime of 5?
You want like the derivative at that specific point?
Yep, good. So can I take a derivative of f of x times g of x?
No, you have to take the derivative of F5 and G5, or
No? Yes?
Well, would you first find like the equation of the g of x of y and then the equation of the f of x of y, and then find the derivative of that?
Yeah, but that would be too complicated. That'd be too complicated. Yes.
you can just find the slope of both of them at 5.
Yes, you need to do that, but not yet. Yes, Caroline?
Just find where, x is 5 and what's y for f of x and g of x.
Okay, you need that too? Yes, Sarah?
Couldn't you just find the derivative and then plug in 5?
Yep, so what is derivative of f of x times g of x?
Isn't that just like product rule?
Yeah, that's a product rule. So what will be the product rule in this case?
F prime or
F prime,
of x
x, right?
times
G of x,
plus g prime of x times f of x.
g prime of x times f of x. Does that make sense?
Yeah.
So if I have h prime of 5, so that means f prime of 5 times g of 5, does that make sense? Plus g prime of 5, so f of 5. Are we okay here? Now what's f prime of 5? If I have a graph there, how do we use that graph? Will be what? No. 2 over 3, good. If you see from this point, what is this? Plus 2, right? Plus 3, right? So it'd be 2 over 3, so right overrun. So how far I change in y and how far I change in x, right? So it'll be what? 2 over 3. Does it make sense? Does it make sense for everybody? Because derivative is the slope. Does that make sense? Okay. What is g of 5? G is a red line or blue line? What? What is, who says what? Negative 4? Okay. Sydney, is that what you say? Okay, good. Okay, anybody else can contribute what g prime of phi is? Trevor, can you tell me what g prime of phi is?
It's gonna be 6, is it 6 over 5?
No.
Oh no, 6 over 3?
No.
Is it 3 over -6? That'll be -1/3.
No.
Negative 2?
What is it?
Negative 2?
-2 is good. Why is it -2? You look at this point, right? How far they go down? -2, right? How far they go right? +1. So it'd be -2 over 1. Does that make sense? Does that make sense or no? Yes? Caroline, does that make sense? Does it make sense for everybody? And what's f of 5? 4. So therefore, it's going to be -8 over 3 and -8. Does that make sense? So it'll be 3, and that's going to be -24. I think this is 3 over 3. So that's 24. 24 minus 8. 24 plus 8 is 32. So -32 over 3. So the answer is -32 over 3. So this is called a generic derivative. But make sure you have to understand, when I ask you f prime of 5, that means, so f prime at something, right? At 2, that means slope at x equal to 2 for f of x. Does that make sense? Now, if I ask you what is f of 2, that means the output at 2, at x equal to 2. What is the y value? So on your homework, you're gonna have a question like this, and you have to figure out what you're supposed to do. Got it? So maybe something is a little bit harder, and this is the case that you might have some problem. It's called generic derivative. AP exam love it. They love the way they ask that question. They think it's cute.